What is division? A guide to division at Moorfoot Primary School. Division begins at the early level. We start by asking pupils to split items into equal parts, and we ask them to take part in practical activities. This may be, can we share these sweets fairly? How would we do that? How would they each get the same number of sweeties? We have this pizza. How many pieces do we have now? Let's give out 6 pieces of chocolate to these 3 friends. How many groups do we have now? How much chocolate do they each get? And then we begin to look at leftovers, or as we will call it, remainders. The next step is introducing it formally using real objects or pictures. Pupils begin sharing independently. Sums become formal. 8 divided by 2. This may be represented by pictures. For example, the stars that are on this picture just now. We may ask the pupils to collect cubes and distribute those into 2 groups. We may ask them to score out the stars as they distribute them into 2 groups. It's a more practical approach to answering the sum. We may also include scattered arrays. At this point, we would begin to look at the remainders. If you were splitting this group into a group of 5s, would there be any left over? Well, we can see from this picture that there would be 2 clear groups of 5. Onto this picture. Can we arrange this into groups of 6? As soon as we've done that, we can see that there's 1 left over. This is where children begin to look at remainders. A scatter array is a good opportunity for children to see the visual behind the meaning of that answer. We may also use them to identify patterns and simpler ways of identifying a number, and in this case the number 5. The picture on the left has a 5 grouped in the same way as a dice. Once children start to begin to see these patterns, it helps them to answer their questions quickly. We may begin to record work using pictures and practical activities. Here is one example, a number line. 18 divided by 3. We can begin by counting up in jumps of 3. 1, 2, 3. That's 1 jump. 1, 2, 3, 2 jumps, 3 jumps, 4 jumps, 5 jumps, 6 jumps. So we know it takes 6 jumps. That means that there's 6 sets of 3 in 18. The same would be true if we counted backwards from 18. Using arrays again for more complex questions. 15 divided by 3. You can see here that there are 15 counters. How many rows are there? 3 rows. Now we've split it into that number. We've got an answer. So we've taken the 15 counters, split them into 3 rows, and look, we now have 5 counters in each row. That gives us our answer. Here's another example. There are 20 counters. Can we split this into groups of 4? So our sum here would be 20 divided by 4. Let's watch us splitting this into groups of 4. We've got 2 groups, 3 groups, and 4 groups. How many is in each group? 1, 2, 3, 4, 5. So that means that 20 divided by 4 groups will be 5. Now we're going to look at remainders. We begin to record remainders using the same strategies and same methods. We might share out practical items in pictures and see how many are left over, just similar to the way we were speaking earlier about the stars. We may give out 10 cubes and ask them to share amongst 3 boys or girls, and that visually would show us the leftovers. We may also use a number line. This time we started at 14 and we counted backwards. Let's count backwards in a jump of 3. We know 1, 2, 3, that's 1 jump. 1, 2, 3, that's 2 jumps. 3 jumps. 4 jumps, but oh, we have 2 left over. We know we need to make it into sets of 3, so that gives us 2 left over. So that would be 1, 2, 3, 4 sets of 3 and 2 left over. So 14 divided by 3 would be 4, remainder 2. Here is another example of finding remainders. In this picture we have 28 counters. We're to divide this into groups of 5. We've done this, and as you can see there are 5 groups of 5 in the number 28. But equally we can tell straight away that there are 3 left over. We cannot make another group of 5. So our answer is 5 remainder 3. We may also begin asking pupils to find halves and quarters and thirds. Pupils will know at this stage a half means 2 pieces. We're sharing it into 2 groups. When we share it into 2 groups, how many do we have in each group? We say it 10 in each group, so a half of 20 is 10. Let's look again at those patterns to try and identify simpler ways of counting. We can see a group of 4, a group of 4 and a group of 2. And that would hopefully help our children to identify quickly that that is 10. At the first level, we would also begin looking at division strategies. How many times can you take 2 away? So 12 divided by 2. You can take 2 away 6 times, so 12 divided by 2 would be 6. This is a similar situation to finding how many 2's are in 12. How many groups of 2 are there in 12 we know is 6. Or we may look at multiplication. 3 times 2 is 6. So if 3 times 2 is 6, if we double that, 6 times 2 would be 12. Or 3 times 2 plus 3 times 2, they both equal 6, and 6 plus 6 is 12. We may also use times tables. We may know that, as we said earlier, 6 times 2 is 12, so 12 divided by 2 is 6, and also 12 divided by 6 is 2. We're trying to learn those relationships between the numbers. We may also use double and halves. Half of 12 is 6, and as I said, a half is the same as dividing by 2. Pupils also begin to divide larger numbers, 100 divided by 5. They can still use arrays, number lines and times tables. They may begin to break the number into smaller pieces. 100 is made up of 50 plus 50, so if we divide both of those by 5 in this following procedure, 50 divided by 5 is 10, 50 divided by 5 is 10. If we put those answers together, it gives us 20. So 100 divided by 5 would be 20. Pupils may also begin to use vertical sums. Here's an example of solving that sum. We would begin by asking the pupils, how many sets of 7 are there in 1? You may want to take a visual representation of that, something concrete, maybe a cube, or even just one finger. Can we make a set of 7 with just one cube? No, we can't. So our next step would be to do this. We would take the 1 over to this 8. Now it's not just 1 plus 8. We would spend a lot of time explaining to the pupils about place value, so we would know that this column is hundreds, tens and units. So we move this 1 over, it is more than just the number 1 here, so it makes this number 18. How many sets of 7 are there in 18? Again, you may want to take out 18 cubes. You may want to use a number line or your times tables. So we're going to do some jumps. 7, 14, That's 2 jumps. But the next jump's 21. That's not going to work because 18 is lower than 21. We can't go any higher than 18. Well, we know we've got 2 jumps to 14. So straight away, we can put that 2 in. But that 18 isn't going to disappear. And while we know we've got 14, we haven't quite made it to 18. So let's see how many jumps it would go from 14 to 18. 15, 16, 17, 18. That's 4 jumps. So that 4 is added on to this 4. And again, we would speak about place value. 44. How many sets of 7 are there in 44? Well, I would go through my stations of the 7 times table. Let's see, we've got 7 5s, 35, 7 6s, 42, 7 7s. Oh, now, we don't have 44. 49 is too high, so we can't use that. So we would go to our 42. How many 7s were in 42? 7 6s. But there's a remainder because we did not have the 42, we had 44. How many jumps between 42 and 44? 43, 44. That's 2 jumps. So I now know that's a remainder 2. That's just one way of solving that. You may be able to explain to us a different method, and we would love you to share that with us. Once the pupils are at the 2nd level, we will still be encouraging them to build on the same strategies. Some pupils may still need to work using concrete materials like cubes. They may need something visual like this number line that we are going to look at. 121 divided by 7. How many groups of 7 can we make from 121? This time the number line is a little bit more complex because we know that 10 groups of 7 is 70. That's one part of our journey to 121. The next part, 7 5s, that would take us to 35. We would add that onto the 70. That would give us 105. 2 7s would give us 14. And that would give us 119. So how many groups of 7 did we make there? Well, let's look at the ones in the red. We made 10 groups, then 5 groups, then 2 groups. So altogether, we made 17 groups. And that took us to 119, but we still had 2 left over. That's just one way of trying to solve that, one strategy, rather than a formal sum. This encourages the children to use what they already know in maths and to help them find a visual representation of that groups of 7. We encourage pupils to use times tables as a strategy. We mentioned this earlier. 56 divided by 8. Well, if we know that 7 times 8 is 56, okay, well, if we know that 560 divided by 8 would be the same as 70 times 8, we begin to see these relationships. So 56 divided by 8 would be 7. So 560 divided by 8 would be 70. Beginning to see these relationships are key to solving these types of questions quickly. We encourage pupils to use those strategies for larger numbers. Partitioning. 864 divided by 8. Rather than do this as a sum, we can do this mentally. Let's take that number and split it into 2 pieces. 864. Divide each part by 8. Let's divide 800 by 8. That would give us 100. 64 divided by 8 would give us 8. We put those together, the final answer is 108. We encourage pupils to use those strategies for larger numbers. This strategy is called partitioning. 855 divided by 8. Split this number into 2 pieces again, this time into the 800 and the 55. We again divide 800 by 8, that gives us 100. But when we divide 55 by 8, we may use one of our strategies to work out the remainder. We would know that there is going to be a remainder of 7 because 8 6s are 48. So our final answer would be the 100 plus that 6 and then the remainder of 7. Let's look again at 864 divided by 8, but this time using a different method. We may return to halving. We know that to divide by 8, it is the same as halving 3 times. So we halve 3 times. Let's try that with this example. We are going to partition 800 and we're going to partition that 64 again. Let's partition the 800 first and halve it. That gives us 400. Let's halve the 64. That gives us 32. Let's halve it again. Half of 400 is 200. Half of 32 is 16. Let's halve it one last time. Half of 200 is 100. Half of 16 is 8. So our final answer is still 108, but just with a different method. We may also begin looking at dividing by 10 or by 100. We would also include decimals at this stage. We may move each digit, but we cannot use the decimal point at this point. We do not speak about the decimal point moving, and I think this is an important part of the division lesson. When you look at 250.9 divided by 10, it is clear when you divide it by 10, you simply move all the digits one space to the right. To the right is always going smaller. So if we move the 2 from the hundreds to the tens column, the 5 from the tens to the units column, the 0 from units to tenths, and tenths to the hundredths, we now come out with 25.09. Had we moved a decimal, it would become confusing